Hello everyone. Today I'm going to talk with you about the periodic table, and to do that we start with how an atom is shown in the periodic table. The first thing you will always see is the symbol. So if you take for example carbon, the symbol for carbon is a C, which under it there's the name, so C and then carbon. Then to the left you have the atom number, which for carbon is 6, and this is, if you read the periodic table from left to right and from top to bottom, carbon will be in the sixth spot, and the atom number equals the number of protons in the core. And if you remember from the last video, for a neutrally charged atom, that equals the amount of electrons in the electron shell. You then have the atomic mass, which is 12.01, and this means that carbon weighs 12.01 grams per mole of carbon. Uh, and for atomic masses, we take that the mass of a proton equals 1, and for a neutron equals 1, and electrons are so light that we say that equals 0. So if you want to know the amount of neutrons that are in the core, you take the amount of neutrons, you take the atomic mass minus the amount of protons, which equals the atomic number. So in this case, it's 12 minus 6, so you have 6 neutrons in the core of carbon together with 6 protons and then 6 electrons. Then to the left you have the electron configuration, which for carbon is 2, 4, and this shows the way the electrons are around the carbon core. So if we take the Bohr model again, like from last video, you have a core, and then around that you have the first shell. So that's the 2, which says, well, there's 2 electrons in it. And when the first shell has 2 electrons in it, it is full, so it's gonna need the second shell. And then that 4 says, okay, there are in this shell 4 electrons. Then the last thing you see in the periodic table is the oxidation number. For carbon, that's 4 plus, 4 minus, and 2 plus. And this says if you see carbon as an ion, so instead of a neutrally charged atom, an ion is charged, you will find C4 plus, C4 minus, and C2 plus. And why these numbers are the numbers for carbon, I will tell later on in the video. Now look at the periodic table. You see that the periodic table is conscribes of vertically columns and rows, and a row in a periodic table is called a period. And then you have the groups, which are vertically. You have 18 groups. You see one special case, which is over here, the lanthanides and the actinides. All those atoms over here are all very similar to the first one. So these from the first row are all very similar to lanthanum, which should be here. And the same goes for this. So all these are similar to the first one, which is normally here. You then have 3 special groups in the periodic table, which I will discuss with you. The first one is group 18, which are the noble gases. So the noble gases. And if you look at the noble gases in the periodic table, you will always see that the oxidation number is always 0, so they will never have a charge. In other words, they will never react, and the electron configuration will always end. Electron configuration will always end on 8, except for helium, which will end where it will end on 2. This is because helium only has a full first shell, which only fits 2 electrons, while here it fits 8 electrons. The next I will discuss is the halogens, which is group 17. Halogens. And if you look at them, you will always find that the oxidation number will be 1 minus, and that the electron configuration will always end on 7, which means that they are just 1 electron away from being the same as a noble gas, so for having a full outer shell, which means they won't react and they will be stable. And because they are so close, they will very easily react with all other molecules to fill that outer shell and thus start being stable. And then the last one, which is pretty similar to halogens, are the alkalines. Which will all have an oxidation number of 1 plus. And the electron configuration will always be 1. And just like where the halogens are have 1 electron too few to be like a noble gas, these all have 1 too many, which means they will really easily get rid of an electron so that the outer shell is full. So you will always find an H plus or an Na plus or a K plus, because they want to be like a noble gas, because these are the most stable. So they want to get rid of that 1 electron that they have too much, but then they of course have 1 proton more than electrons, so they will get that positively charged. And you will always find in reactions that an halogen and an alkaline will always very easily react with other molecules, such that they will have a full outer shell and will be as stable as they can.